Hello students, welcome to our channel. In this video, I am going to discuss some basic questions on the atomic structure. Let us see our first question. So, Rutherford's alpha particle scattering experiment proved that atom has. So, Rutherford's experiment proved that atom has nucleus. So, option 3 is the correct option. Second question. So A and B are two atoms which have same atomic weight are having atomic numbers 27 and 30 respectively. If atomic weight of A is 57, then atomic number of then neutrons in B is asking in the question. Let us see, there are two atoms are there, A and B atoms. So atom A atomic number which is a Z, that nothing but 27, and atom B atomic number is 30. Now if atomic weight, if you see, both atomic weight also same only. So atomic weight, it is 57 and this is 57, and asking about number of neutrons. So to calculate number of neutrons, we have a formula that nothing but atomic weight minus atomic number. Atomic weight nothing but the 57 and atomic number of B nothing but it is 30, so it is 27. So in this question, the number of neutrons in B is 27. Option 1 is correct option. Next question. Find out the atoms which are isoneutronic. Isoneutronic means they have same number of neutrons. Same neutrons. Let us see with the first option. So carbon 14 with atomic number 6. So number of neutrons equal to atomic weight is 14 and number of protons are 6 here. Number of neutrons are, it is 8. So it has 8 neutrons with first option with carbon. Let us go with the nitrogen. So for nitrogen, so it has 8 neutrons in this case. For nitrogen, number of neutrons is equals to the 15 minus 7, that has 8. So this also has 8 neutrons. Next, fluorine, if you see, fluorine 17 it is given. Number of neutrons equal to 17 minus 9, which means 8 neutrons are present. That means it also has 8 neutrons. So the first option, in this case all of the atoms having same number of neutrons. So option 1 correct option. Next question. Species which are isoelectronic. Isoelectronic means they have same number of electrons. Let us see number of electrons in the given species. Here 6 plus 7 plus 1, okay, so which means it is a 14. So in this case 8 plus 1 plus 1, it is 10. In N2 it is 7 plus 7, it is 14. In CH3, that is 6 plus 3 minus 1, as it is given positive charge. So this one has 8 electrons only we have. Next, carbon monoxide, 6 plus 8, it has 14. So A, D, E, this has the same number of electrons, so option 3 is correct option. Next question. For any anion X3 minus, the mass number is 14. So X3 minus mass number is 14. If anion has 10 electrons, then number of neutrons in X2 nucleus is asking in this question. Let us observe here X3 mass number, X3 has 10 electrons. That means number of electrons in X, number of electrons in X, that equal to 7 electrons. In neutral atom, number of electrons equal to number of protons. That means number of protons, how much it is? Number of protons also 7. So if number of protons are 7, atomic weight is given 14. That means number of neutrons in X is equal to how much? Number of neutrons, that nothing but atomic weight minus number of protons. Atomic weight is 14, atomic number is 7. Total will be 7 neutrons are present. So number of neutrons in X is equals to the number of neutrons in X is equals to 7 means number of neutrons in X2, number of neutrons in X2, that nothing but 7 plus 7, that nothing but the 14 neutrons are present in this. So option 2 correct option. Next question, choose the false statement about deuterium. Deuterium is an isotope of the hydrogen. So option 1 is the correct statement. It contains an electron, proton and neutron. This also correct only. So deuterium has atomic number is 1, mass number is 2. So it contains one electron, one proton and one neutron. That means option 2 also correct statement. So they have asked about false statement in this case. Now it contains only one proton and one neutron only given, but it also contains electron. That means it is a false statement. That is, it is our correct answer. And D2O called as a heavy water. That means fourth also correct one only. Okay, so option 3 is the correct in this case. Next question. The relative abundance of two rubidium isotopes of atomic weights are 85 and 87, and the percentage abundance given 75% and 25% respectively. The average atomic weight of the rubidium is asking in this question. Okay, right, let us see the percentage abundance, like a the two isotopes are there. So Rb85, that nothing but 75%, and we have one more Rb87, we have 25%. Now we know average atomic weight formula. Average atomic weight, that is equals to the percentage abundance into atomic weight. Percentage abundance is 75 into atomic weight is 85 divided with 100 plus percentage abundance of 87 isotope is 25% into atomic weight is 87 divided with 100. This is the average atomic weight of the element formula. Okay, let us see what is this value exactly coming. Right, 75 into 85 divided with 100, this value comes as a 61.37 plus 25 into 87 divided with 100, this value coming as 24.18. Okay, right, by adding this one the answer will be the 85.55 is coming. So option number 2 is the correct option. So this is the percentage abundance and atomic weight question. Next question, the ratio of specific charge of the proton and alpha particle they have asked. So we know what is specific charge. Specific charge means charge to mass ratio. Charge to mass ratio is considered like a specific charge. Now let us go with the first of all with the proton. In case of proton, so specific charge is specific charge, that nothing but, so it is a charge is a relative charge is 1, Relative mass also 1. In case of alpha particle, specific charge, that equal to the, what is the alpha particles? It is a bipositive helium ions. So He2 plus ions. So the charge is 2 and mass of the helium particles are 4 times of mass of the protons. So if you take the proton and alpha particle specific charge ratio, if you take that, nothing but 1 divided with 1 by 2. It is 1 by 2, is a 2 ones are 2 twos are. Okay. So the ratio is 2 is to 1. Option number 1 is the correct option for this question. Next question. In an atom of aluminum 27, the number of protons is A, number of electrons are the B, number of neutrons are C. Hence the ratio of C is to B is to A. Okay. Observe this one. They are asking about the neutrons, electrons, proton ratio asking. Okay. Let us see in aluminum 27 isotope. What about the number of protons? Number of protons is equals to 13. That means it is a neutral atom. Number of electrons also 13. Electrons also 13. And what about number of neutrons? Neutrons equal to atomic weight minus number of protons. That means it is 14. So protons, that nothing but A, electrons are nothing but B, neutrons nothing but C. So the ratio is the ratio of C is to B is to A, that nothing but 14 is to 13 is to 13. So option number 3 is the correct option for this question. Next question. Atomic weight of neon. It is a average atomic weight only, that is 20.2. Neon is the mixture of neon 20 and neon 22. Relative abundance of heavier isotope asking. Heavier isotope means neon 22 only asking in this question. Okay. Let us see. We know the formula to calculate average atomic weight. And before that, there is two isotopes, neon 20 and it is neon 22. Assume that the percentage abundance of neon 22 I am considering like a x percentage. If I take neon 20 percentage abundance is 100 minus x will consider. For easy calculation I am taking this way. Okay. You can take neon as a x, neon 22 as a 100 minus x also we can take, but this will give easy calculations here. Let us see the average atomic weight. So we know formula. So percentage abundance into atomic weight, which means 100 minus x into 20 plus x into 22 divided with 100. Atomic weight of neon is given already, which is 20.2 in the question, which means 20.2 that equal to, so 22x plus it become 2000 minus 20x divided with 100. So this value is 2020, that equal to 2x plus 2000. So here is 2x equal to 20, x equal to 10%. That means the heavier isotope we have 10% it is there. So option 4 is the correct option. Next question. The number of protons, neutrons, electrons in the element 23189, it is given. Right. Here if you see in this case, number of protons, that nothing but atomic number, it is 89. As it is given neutral atom, number of electrons also, it is 89. Now let us go number of neutrons. Number of neutrons is equals to the atomic weight, which is a 231 minus 89, and it gives 142. So option, they have asked about the protons, neutrons and electrons are given in this question. So option 3 is the correct option for this question. Next question. The E by M ratio is maximum for E by M ratio, that nothing but the charge to mass ratio. It is charge to mass ratio. Let us take relative charge and relative mass. Let me take with the D plus first of all. D plus charge is 1, mass is 2, it is 1 by 2, and it is a helium plus. For helium plus, charge is given 1 plus, here 1 divided with 4, as it is the mass of the helium, I answer 4. Next H plus, it is a mass is, so charge is 1, mass also 1. Next one He2 plus, it is 2 divided with 4, which means 1 by 2. So the maximum in this case, that is for the H plus. Next question. Right. In N147, if mass attributed to electrons were doubled, so mass attributed to electrons are doubled in this case, but mass attributed to protons were half. So regarding electrons it is doubled, regarding protons it is half. The atomic mass would be approximately is asking. Okay. Observe carefully here. Here in case of N714, the number of protons is equals to the number of protons, that equal to 7, and number of neutrons equal to also 7. Number of neutrons, how to find? Atomic mass minus 7. So it is also 7. So in the given question, the mass of the protons, that become half. So let us take same, the number of protons are half. So the mass of the protons, if you see, mass of protons, that becomes 7 by 2, so which means 3.5. If you consider the new atomic mass, that nothing but protons are 3.5, neutrons are 7, which means it is a 10.5. That means the atomic mass decreased from 40 to 10.5. Atomic mass is decreased from 14 to 10.5. Let us see how much percentage it is decreased to. Okay. So percentage decreased, that equal to 14 minus 10.5 divided with total mass is 14 into 100. This value is a 3.5 divided with 14 into 100, that nothing but 25%. That means percentage decrease is equal to the 25%. So our option 3 is the correct option for this question. Next question. The value of Planck's constant is 6.63 in 10 power minus 34 joule second, and the velocity of light is 3 into 10 power 8 meter per second. Which value is the closest to the wavelength in the meters of quantum of light with frequency 8 into 10 power 15? Okay, let us see here. Question asking regarding wavelength. We know the wavelength is equals to the c divided with nu. C divided with nu. So c means speed of light, nu means it is frequency. That means lambda equal to c value given in the question itself, which means 3 into 10 power 8 divided with the frequency of light is 8 into 10 power 15. This one I am writing as a 30 into 10 power 7 divided with 8 into 10 power 15 for easy calculation. So this become 30 by 8, it become 3.75 into, if 15 if you write in the numerator, it become 10 power minus 15. Now if you subtract 10 power minus 7, it become 10 power minus 8 meters will come. So option number 4 is the correct option. Okay. Next question. The energy of 1 mole photons of radiation having frequency 5.01 in 10 power 14 hertz, and asking about what energy is asking. Let us see. We have formula E equal to h nu. This is for energy of one photon. Energy of one photon. And question asking about 1 mole of photon. That means energy equal to n h nu. Here n equal to 1 mole. 1 mole means Avogadro's number. That means E equal to 6.023 into 10 power 23, and Planck's constant value 6.626 into 10 power minus 34 joule second into frequency given 5.01 into 10 power 14. We'll simplify this. E equal to 6.023 into 6.626 into 5 into 10 5.01 into 10 power 37 into 10 power minus 34. So E equal to, so we know 6 5s are 30, 30 into 6.6. So it is around 200. So I can say it is around 200 into 10 power 3 joules. Okay, this becomes 200 kilojoules. Kilojoule per mole we can say. So option 3 is the correct option for this question. That's it about this video. Remaining questions I will upload in the upcoming video. Thank you.